Assalamualaikum and hi guys. So today we will continue for the properties of the inverse Laplace transform. So there are three properties for the inverse Laplace transform. The first one is the linearity of the inverse Laplace transform, first shift of inverse Laplace transform, and inverse Laplace transform of rational function. For the first properties, linearity of inverse Laplace transform, you can refer to the textbook page 139. So Laplace inverse Fs is equal to Ft. Laplace inverse of Gs is equal to Gt. If alpha and beta are constants, then Laplace inverse alpha Fs plus beta Gs, so the whole thing in the same curly bracket, will become alpha Laplace inverse Fs plus beta Laplace inverse Gs. So as we can see here, we already bring the constant, which is alpha and beta, to the outside of the curly bracket. Therefore, the answer will become alpha multiplied with the Ft plus beta multiplied with the Gt. So let us try to solve this example. You can refer to the textbook page 140. Find the inverse Laplace transform of the following functions. So example A here, you are given Fs is equal to s plus 3 divided with s square minus 16. In order to apply the linearity properties, you have to refer to the upper side here. If you have the plus or minus operation, so you have to know that you have to apply the linearity properties. Okay, so don't refer to the bottom side here. The bottom side is for you to refer to the table of the Laplace transform. So for the example A, we have s plus 3 divided with s square minus 16. So the first thing, you have to write the notation of the Laplace inverse, curly bracket for the whole thing. So now, by referring to the upper side here, we have a s plus 3. So you have to separate the upper side. Now we have only one Laplace inverse in the curly bracket. Then when we separate the upper side, it will become Laplace inverse, the first curly bracket, plus Laplace inverse, the second term for the curly bracket. Okay, so for the first term in the curly bracket, this one will become s over s square minus 16. The second term in the curly bracket will become 3 over s square minus 16. After we have separated the upper side, so now you have to refer to the table of the Laplace transform, for which one that is suitable for the Laplace inverse s at the upper side divided with s square minus a square at the bottom side. So for this one, the suitable one is hyperbolic cos of at. So for the second one, Laplace inverse of 3 over s square minus 16. So we have a at the upper side. So the suitable one is a over s square minus a square, which will become hyperbolic sine of at. So now we have to write the answer for the Laplace inverse s over s square minus 16. So before you want to write the answer, you have to determine what is the value of a. So from here, we have a square is equal to 16. So our a is equal to 4. So the same thing for here, we have a square is equal to 16. Our a is equal to 4. So we only consider the positive value of a. So Laplace inverse s over s square minus 16, s over s square minus a square will become cos h of at. So our a is equal to 4. So our answer will become cos h of 4t plus Laplace inverse 3 over s square minus 16. So we have a constant at the upper side here. So constant you have to bring to the outside. So we bring 3 to the outside. Laplace inverse. The upper side will become 1 over s square minus 16. So now in order to solve for the Laplace inverse 1 over s square minus 16, our a is equal to 4. So you have to write this one in terms of a over s square minus 16, whereby our a here must be written as 4. So we write 4 here, means that we have to divide 4 at the front. So you can write as 16 here, or you can write as 4 the power of 2. Plus 3 over 4 is a constant, 3 over 4. Laplace inverse 4 over s square minus 16 will become sin h of a t. So whereby our a is equal to 4. Sin h of 4t. So this is the final answer for the inverse Laplace transform for the example A. Okay, now let us continue for the example B. You are given fs equal to 2s plus 7 divided with s square plus 4. So the first thing, you have to write the Laplace inverse, curly bracket for the whole thing. So if we have a plus or minus operation at the upper side, means that you have to apply the linearity properties. So you have to separate the terms 2s plus 7. So it will become Laplace inverse, the first curly bracket, plus Laplace inverse, the second curly bracket. So for the first curly bracket, we will write as 2s over s square plus 4. The second curly bracket, we will write as 7 over s square plus 4. So now, before we want to refer to the table of the Laplace transform, if you have any constant at the upper side, so you have to bring the constant to the outside. So we will bring 2 and 7 to the outside. So for the first curly bracket, we will bring 2 to the outside. So the upper side will become s over s square plus 4. For the second curly bracket, we will bring 7 to the outside. So the upper side will become 1 over s square plus 4. So you have to refer to the table of the Laplace transform, whereby you have s at the upper side and you have s square plus a number at the bottom side. So the suitable one is s at the upper side, s square plus a square at the bottom side, which will become cos of at. For the second Laplace inverse, we have a number at the upper side, so the suitable one is a over s square plus a square, whereby the answer will become sin of at. So therefore, for the first curly bracket, 2 as a constant at the front will become 2 multiply with s over s square plus 4. For this one, our a is equal to 2. A square is equal to 4. So therefore, a is equal to 2. So the same thing for here. Our a is equal to 2. So s over s square plus 4, this one will become cos of at. So we substitute our a for the cos of at. Cos of 2t plus 7 Laplace inverse 1 over s square plus 4. So for this one, the upper side is 1. In the table is a at the upper side. So you have to write Laplace inverse 1 over s square plus 4 as the same term as a over s square plus a square. So 1 here must be written as A. 7 Laplace inverse 1 should be written as 2. 2 over s square plus 4. So now, when we write 2 at the upper side, you have to divide with 2 at the front. So divide with 2. So now simplify the answer. 2 cos 2t plus 7 over 2 Laplace inverse 2 over s square plus 4. So this one will become sine of 80. 7 over 2 sine of 2t. So this is the final answer for the inverse Laplace transform example B. Next, for the example C, 3s minus 6 divided with 4s square plus 16. So now we have a constant beside s square. Okay, so for the first step, you have to write Laplace inverse, curly bracket for the whole thing. For example B, we don't have any constant beside s square at the bottom side. So we can directly separate the terms. But now, we have a constant beside the s square. So you have to factorize the constant first beside the s square. So therefore, Laplace inverse, still in the same curly bracket, 3s minus 6 divided with 4, make it in bracket. Okay, so when you factorize 4, it must be still in the same curly bracket. 4 multiply with what? So that it will become 4s square. So 4 must be multiplied with s square plus 4 multiply with what? So that it will become 16. So 4 multiply with 4. So now we can separate the terms at the upper side. So separate the terms. As we can see here, you have a minus operation. So you will have Laplace inverse first curly bracket minus Laplace inverse second curly bracket. So for the first curly bracket, it must be written as 3s over 4 multiply s square plus 4. 3s over 4 multiply s square plus 4. For the second curly bracket, will be written as 6 over 4 multiply s square plus 4. 6 over 4 multiply s square plus 4. So now, if you have any constant, so you have to bring the constant to the front. So the constant 3 and 4, you have to bring to the front. So the same thing for the second curly bracket, you have 6 and 4. So bring the constant to the front. 3 over 4, Laplace inverse. So when we bring 3 to the front, the upper side will become s. S over s square plus 4. Bring 6 and 4 to the front. So 6 over 4 will become 3 over 2. Laplace inverse. When we bring 6 to the front, the upper side will become 1. 1 over s square plus 4. So now, you have to refer to the table of the Laplace transform, whereby we have s at the upper side and we have s square plus a number at the bottom side. The same thing for the second curly bracket, you have to refer to the table of the Laplace transform, whereby we have a constant at the upper side and we have s square plus a number at the bottom side. By refer to the table, whereby we have s at the upper side and s square plus a number at the bottom side. So this one is the suitable terms, whereby the answer will become cos of 80. For the second inverse Laplace transform, the suitable one is sine of 80. So now, from the first curly bracket, you have to determine what is the value of a. So our a square is equal to 4. So therefore a is equal to 2. The same thing for the second curly bracket, whereby our a square is equal to 4. So therefore our a is equal to 2. So now write the answer based on the table of the Laplace transform. Laplace inverse s over s square plus 4 will become cos of at. So substitute our a is equal to 2. 3 over 4 cos of 2t minus 3 over 2. For the second Laplace inverse, the upper side here in terms of number 1. Based on the table, the upper side is a. So we have to write 1 in terms of a, whereby a is equal to 2. Laplace inverse. So whereby we write 2 at the upper side, you have to divide 2 at the front. S square plus 4. Simplify 3 over 2 divide with 2 will become 3 over 4. Laplace inverse 2 over s square plus 4 will become sine of at. Sine of 2t. Okay, so this is the final answer for the inverse Laplace transform example C. For exercise 4.6 page 141, so this one you have to do it as your own exercise.